Hello, everyone, and welcome to section 2.5 in Precalculus, zeros of polynomial functions. So you should try to fill in the following on your own to see how much you already know about zeros. This is not new information, but of course I am going to fill it in for you. If x is equal to a is a zero of f of x, then x minus a is a factor of f of x. And the point A0 is an x-intercept. So I'm always trying to get this point across to you that zeros, factors, and x-intercepts are intricately related. Zeros actually are x-intercepts. They just are expressed differently. And then the factor always includes the x-intercept. If a zero occurs twice, then the graph of the function bounces at a comma 0. If the 0 occurs 3 times, then the graph of the function passes through. That point. It also flattens out just a little bit. I don't want to make too big a deal of this because it doesn't become really flat, but flattens out a bit. The easiest way to find zeros is to set your equation equal to 0 and factor. Today we will look more closely at the equations where zeros cannot be obtained because the equations cannot be easily factored. So this is our plan. First, we're going to locate as many zeros as possible using the graphing calculator. Second, we're going to use the zeros that we found and synthetic division to keep reducing the polynomial until it reaches quadratic form. And then we're going to use either factoring or the quadratic equation to find the last 2 zeros. So we're actually going to stop here, and I'm going to switch over to the calculator to show you how to do the first one. So our first step is to go to our y is equal to and type it in. I tried to make the video ever so slightly shorter by typing it in already. And then I go to graph. So when I graph, I feel like I can already see 2 of the zeros. I feel like I can see that it's at -3, and it looks like it might be at 1. So there's 2 different ways to find zeros. One of them is to use the zero feature, which we're going to do for this one that I really can't see. But another thing is keep in mind that sometimes you can just look at the table. So second graph will give you the table. And sure enough, do you guys see this? -3 is a 0 and 1 is a 0. And I don't see any other zeros. But that's one thing you can do, which is a little faster than what I'm about to do now. So what I'm about to do now is I'm going to find this one right there. I'm actually going to change my window a little bit to blow it up. It makes it easier to see. Zoom 4 is a really lovely window. So I feel like this is somewhere between 0 and 1. So I'm going to do a calculation. This is for calculate. Second trace is calculate. And there it is. I want to find a 0. And then it's going to say, what is the left bound? It just means, like if I wanted to find this 0, I'd say, oh, it looks like it's between -5 and -4. But I want to find this one that looks like it's between 0 and 1. So I would say 0. Now I already know that there's a 0 at 1. So to make sure I don't find that one, I'm going to say 0.9. So it draws 2 lines. It says, I'm going to find the 0 between these 2 lines. And you're like, awesome. And there it is. It's at 0.5. Then, and then for number 1, you can just list the 3 answers. The 3 answers are 1, 1/2, and -3. Let's do the second one. Y is equal to x to the 4th, don't forget to arrow over, minus x cubed plus x squared. I know there's at least a couple of you that are not actually typing this in. You're like, no, we'll just let you do it, Mrs. Shaffer. Graph. Ooh, so it's x to the 4th. Let me go back to my Zoom 6, my standard one. And look what it does. So it definitely comes down through a point, which possibly is -1, and then possibly 2. But then it's like it tried to be a W, but it kind of failed. So the other zeros are imaginary. It didn't come all the way up and go through the x-axis again. So let's find as many as we can on the calculator. I'm always going to try table first. It might find me something. Sure enough, look at that. -1 is a 0. And do you see the other one? 2 is a 0. So now I have 2 of my zeros. All right, let's go back to the other page. So now that we have the first 2 zeros from our calculator, remember we found out that one of the zeros is at -1 and one of the zeros is at 2. That's the x-coordinates of the zeros. This is very cool what you can do. So I'm going to put -1 in here. Remember, this is always where the x-coordinate goes, and then out should pop the y-coordinate. And since these are zeros, that means that they're also x-intercepts, which means that if x is -1, the y should be 0. So I know I'm going to get a 0 there. But this kind of confirms that I did it right. So I get 1. Remember, add, multiply, add, multiply, add, multiply, add, multiply. And sure enough, it came out to be 0. So there's no remainder. That's the y-coordinate. The other 0 is 2, 0. Now it's important that you don't start over. You need to use your, it has a terrible name, your depressed polynomial. This is called the depressed polynomial. It just means that you've lowered it. It's not actually sad. Depressed polynomial, I'm going to put in my 2. Add, multiply, add, multiply, add, multiply, and I get 0 again, which I knew because remember, this is the x-coordinate and that's the y-coordinate. So now, remember, zeros and factors are directly related. So I know that 2 of the factors of this polynomial are x plus 1 and x minus 2. And what synthetic division does for us is it tells us the final factor. It's x squared plus 0x plus 3. So now when I want to find the zeros, if I set this equal to 0, then one of these parts must be equal to 0. So we know if this is equal to 0, it would be because x was -1. If this factor was equal to 0, it would be because x was 2. This factor isn't quite as obvious, so I'm actually going to write it out. To make this factor equal to 0, I subtract 3 from both sides, and I get x is equal to plus or minus the square root of -3. Remember, you can't leave your answer that way. You must take out the I. So plus or minus I square roots of 3. So find the zeros, -1, 2, and plus or minus I square roots of 3. So you always want to get as many as you can on the calculator. Then second step, use synthetic to reduce the polynomial to something that you can either factor or solve. Notice that when there's an imaginary 0, there's always a pair of them because of the plus or minus. It's always be plus or minus I something. Find all the solutions. So the point of asking this in a different way is just to try and show you that when you're solving something that's equal to 0, it's the same thing as finding the zeros. Same as finding the zeros. To solve when an equation is equal to 0 is the same as finding the zeros. So again, we're going to do that first one on our calculator. Now you can find all of them on your calculator, but if you do that, you're going to get -1.06 and 0.546, which there's nothing wrong with, except that I won't accept them. So it's not that your calculator isn't capable of finding it, but I need to see that you can do it and get the exact answer, which is going to involve a square root. So this time we found 2. And I'm going to make my little synthetic here. Negative 10 plus 15 plus 16 and minus 12. Since I know that 2 is a solution, that means it'll actually be equal to 0. This is the x value, and this is what it's equal to. So I'm going to go ahead and add, multiply, add, multiply, add, multiply, and sure enough, I get 0. So this piece that's left here is negative 10x squared. Remember, dropped to power, it used to be, it's depressed. It used to be x cubed, and now it's x squared, minus 5x plus 6. So I literally am going to take this, and I've factored it to x minus 2, that's the one I found on my calculator, times negative 10x squared minus 5x plus 6. So then you should try and factor it, which I'm just going to tell you right now, we can't factor it. So what is your alternative? Your alternative is always the quadratic formula. If you can't factor, use the quadratic formula. So x is equal to the opposite of b plus or minus the square root of b squared minus 4ac all over 2 times a. Remember that it is usually safer to put this underneath both of them separately. Oop, this is a plus 5. Plus or minus, so what do we have here? 240, but it's going to become positive. Plus 25 is 265 over 20. I could reduce this. So from this point, you could either write it as negative 1/4 plus or minus the square root of 265 over 20, or perfectly acceptable answer is to leave it together, 265 over 20. The 265 does not contain any perfect squares. If you're wondering, how would I know that? You literally just have to try them. So 1, 4, 9, 16, 25, 36. But remember, you only have to try them up to a certain point. It's not like you have to try them infinitely, because as soon as you get to a certain point, 144, even 144 times 2 is already 288. So this is the longest list you would ever have to do, and some of them you can rule out immediately. But it does not contain any perfect squares. So this would be your answer. Complex zeros occur in conjugate pairs. Let f of x be a polynomial function that has real coefficients. If a plus bi is a zero of the function, then the conjugate a minus bi is also a zero of the function. So they are telling you that the zeros are -1, -1, and 3i. So it's your job to know that if 3i is a 0, even though they don't list it, -3i is a 0, because it's always going to occur as plus or minus. So let's actually write our polynomial now. F of x is equal to x minus x plus 1, because it's minus the minus 1. And I'm not going to write it twice. I'm just going to write squared. And then times x minus 3i. And then x plus 3i. Now, you may, this is super important, you may leave your answer in factored form. However, is that big enough for you? You may not have an I in your answer. So this part we need to multiply it out. But luckily it's a conjugate. So remember, when it's a conjugate, you only have to do the first times the first and the last times the last, because the inners and the outers are always going to cancel on a conjugate. And that gives us I squared is -1 times -9 is going to be x squared plus 9. So this is what I mean by you can leave it in factored form. Okay, so your book is always going to multiply this out, which, good for them. That's a lot of work, but there's nothing wrong with this answer. You could type this into your graphing calculator. You can find zeros easier. This is a great form. So there's no reason to multiply it out. But then you might be wondering, how do I check it? So your two choices for checking are using the big worked out solution book that's in the classroom, because it has all these steps and you can just see if this step is there. Or you can just ask a friend if they got the same answer. But remember, I do grade your homework, so it does have to be correct, but you do not have to finish. If you finish, don't complain to me about your homework being too long. All right, now we're going to find a third degree polynomial that has 2 and 4i zeros. And what's the last zero? 2, 4i, and -4i. So you should really stop and see if you can do it on your own. But of course, we'll do it together. So x minus 2, because 2 is a 0, that would make the equation 0. X plus 4i goes with the -4i, and then x minus 4i. Doesn't matter what order you do them in. But you can't leave an I in your answer. So this is going to be x minus 2. You should just have to do the first times the first and the last times the last. The inners make 4ix and the outers make -4ix. And that should always happen. And you might find other patterns that help you go a little faster too. But it is important that you show your work. There we go. If I were to multiply it out, it would be a third degree polynomial, because the x times the x cubed would give me, the x times the x squared would give me x cubed. But there's no reason to multiply it out. So we're going to do something just a little harder now, but I believe in you. You can do it. We're going to find all the zeros given that 3i is a 0. So remember, we know 2 of the 3. We know 3i and we know -3i. There's several ways to do this problem, but I'm going to stick with the way I already taught you, which is if you know one of the zeros, you can plug it into synthetic to get the rest. So I'm going to put the 3i right here. This is going to be crazy. You can do it. 1, 1, 9, 9. Notice I spaced it out a little bit more. It is going to take a little bit more room. So add, multiply. Add, multiply. 3i times 1 is 3i. 3i times 3i is 9i squared. But 9i squared becomes -9. So when I add, my 9 and my -9 cancel, and I just get 3i. 3i times 3i is 9i squared. And again, 9i squared. The I squared is -1, so this becomes -9. And I get 0, which is what I expected. If you thought that was a little tricky, the good news is the second one always is easier. So now I'm going to do the -3i. And that gives me add, multiply. Oh, look how nice this is. I said the next one's always easier. Add, multiply, add. And of course, it came out to be a 0. We know that negative 3i is one of the zeros. So this polynomial factors to x plus 3i, x minus 3i, times, so you do have to think about this. If you want to go backwards, the first one's the last one's the constant and then the x. So it's just x plus 1. They didn't ask you to factor it, though. They wanted to know the zeros. So the zeros are plus or minus 3i and negative 1. Okay? I will show you really quick a second option. If you're really good at factoring, you might have actually looked at this and said x cubed plus x squared plus 9x plus 9. You might have thought to yourself, oh, she said 4 terms was easy to factor. So the x cubed has to be x squared and x. And then the inners, I have a 9x, so there must be a 9 across from the x. And then 9 times what makes 9 for the last times the last. And then that gives me my outers. And then you would have seen that the last 0 was negative 1. And this is what produced x squared plus 9 is equal to 0. That's where that plus or minus 3i came from. X is equal to plus or minus the square root of negative 9, I square roots of 3. Not I square roots of 3, just 3i. So this is a great method for people that are good at factoring. But like I said, I was just trying to stick with the method we had already learned, which is if you know one of the zeros or two of the zeros, use synthetic until you get an equation that you can finish. This one is just slightly different in its directions. This one says the product of linear factors, even if it's an I or a radical. They literally want you to factor all the way. Only x to the first power. You can't have an x squared. So for example, on this last one that we just did, on this last one, they would have wanted you to stop here, not here. This is the product. So product means multiplication problem of linear factors. So honestly, we're just doing another practice problem with a different set of directions, which your book is famous for. So how are we going to get the first one? What are we going to do to get that? X to the 5th. Okay, so go back to your very first page of directions. For every single problem, locate as many zeros as possible using your graphing calculator. Then use the zeros you found in synthetic division to keep reducing the polynomial until it reaches quadratic form. And then use either factoring or the quadratic equation to find the last 2 zeros. So we have to start this off on our graphing calculator and find as many as we can. So let's type this in. Actually, I typed it in. I was trying to be sweet and not take up too much of your time. So I already typed it in. And then I'm going to go to graph. And I look at it. And again, I say to myself, it looks like it crosses at -2 and at 1. The easiest way to check is to look at the table. And sure enough, there's a 0 at -2 and another 0 at 1. But there is something else really important that I want you to see. And that is when we go to do our synthetic, the 1 is a 0 twice. It's a bounce. So keep that in mind as we move forward. So remember that using our calculator, we found the first 2 zeros were -2 and 1. But keep in mind that 1 was a bounce. So we're actually going to use it twice in our synthetic. So I'm going to start with a 1 because 1s are easier to plug in. Don't forget your 0. 0x to the fourth plus 1, not plus 1, just 1 for the x cubed, then 2, then negative 12, then 8. So add, multiply, add, multiply, add, multiply, add, multiply, add, multiply, negative 8, 0. And then I get to use the 1 again. 1. So add, multiply, add, multiply, add, multiply, add, multiply, 0. Just gonna give myself a little more room here. And the last one. Oop, it's a little thick. Negative 2. Add, multiply, add, multiply, add, multiply, add. So see how I got the 3 zeros? So this lets me know that I did everything correctly. So far, I can tell you that this function right here can be rewritten as x minus 1 times x minus 1 times x plus 2. And then remember, this is our last factor. This becomes x squared plus 0x plus 4. X squared plus 4. Which normally would be great, and this would be the answer. If I said factor this problem, this would be the answer. But when it specifically says linear factors, I do have to factor this one more time, which we would not normally do. So how do I do that? Remember, factors are related to zeros. So set it equal to 0. X squared is equal to negative 4. X is equal to plus or minus the square root of negative 4. Which is plus or minus 2i. So x plus 2i and x minus 2i. And that's your answer. Or you may write this with a square. Both of them are acceptable. But this is a little bit strange, and we won't normally do this, but it's good to be able to understand different sets of directions. The order of any of these factors does not matter. All right. Next one. Find the zeros of 3x to the third minus 5x squared plus 6x minus 4. So I am going to make this video just a tiny bit shorter and just write, find the first one on your calculator. I'm not going to torture you with that. You would get 1 as your first one. So then you do the synthetic. Actually, I'll just tell you all the answers in case you decide to work it out on your own and see if you can get these now. But I will obviously go through it because you do have to show your work. So 3, negative 5, 6, and negative 4. Add, multiply, add, multiply, add, multiply, add. So this means one of the factors is x minus 1, and all of this means the other factor is 3x squared minus 2x plus 4. This is another way of writing f of x. So this and this are equal to each other. So how do you know when it's factorable or not? Well, it's got to be 3x next. And it's either going to be 4 and 1, 1 and 4, or 2 and 2. So at most, you have 3 things to try. But I will tell you that none of them work, and because I can see the I in the answer. So I know it's not going to be factorable. So that means that I have to use quadratic. Not factorable, use quadratic. formula. So x is equal to the opposite of b plus or minus the square root of b squared. So negative 2 when you square it is positive 4 minus 4ac all over 2 times a. So remember, safest thing you could do is put them separate. And what does this give me here? 16 times 3 is 48, so minus 44. X is equal to 1/3 plus or minus. So when I think of this as parts I can do, the negative 4 is something I can do. The 11 is something I can't. So this becomes 2i. The square root of negative 4 is 2i square roots of 11 over 6. Now, because the 2 is on the outside of the root, it does cancel with the 6. So I get 1/3 plus or minus I square roots of 11 over 3. So find all the zeros. Always go back and read the question. Find all the zeros. The zeros are, don't forget the 1 that you worked hard for, 1, and then 1/3 plus or minus I square roots of 11 over 3. Or you can have it written together if you want, like it was in the original answer. It doesn't matter. Last one. Find all the zeros of x to the 4th plus 6x cubed plus 10x squared plus 6x plus 9. So we'll do one last one on the calculator here. So like before, I already have it typed in for you. So I type it in, I hit graph, and ooh, so again, I only see 1 0. It looks like it's at -3. I have 2 ways I can be sure. One is I could do synthetic and see if -3 works, but I'm just going to use my table really fast. And sure enough, at -3, it's a 0. But notice that it's a bounce. So I'm going to have to use -3 twice. And I can see now that the other zeros are definitely going to be imaginary because this bump doesn't come back down and go through the x-axis. So those little bumps midair are going to produce that. So I'm going to take the -3 that I found, and I'm going to put it in my synthetic. 1, 6, 10, 6, 9. Add, multiply, add, multiply, add, multiply, add, multiply. And when you get the 0, you know you did it right. But because it was a bounce, you have to use it twice. This is where some kids get stuck. They don't know what to do. Add, multiply, add, multiply, add, multiply, add. So if I were to factor f of x, I would get x plus 3 squared times, that's the other factor, x squared plus 1. But it didn't ask us to do that. I'm only showing you because I'm going to have all different directions on the quizzes and tests. If it says factor, stop here. If it says factor, this is the answer. If it says zeros, then this is the answer. -3, which you don't have to list twice. And then you would do x squared plus 1 is equal to 0. X squared is equal to -1. X is equal to plus or minus the square root of -1. So plus or minus I. Now there's always going to be this number of answers. So when it's x to the 4th, there's going to be 4 answers. We only see 3 because -3 is repeated. All right, I think you are ready to go try these on your own. Good luck with your homework.